Hi, folks, and welcome to Physics with Captain Rod. I'm making this video to help you answer the question that I know is burning on everyone's mind. What is displacement? So, this young lad right here, this is Timmy, and I use Timmy in a lot of my example videos. And when you're studying the motion of an object, typically the first thing you do is you define a coordinate system, which I've done here. I've already got kind of an X and Y. Now, coordinate systems, in the majority of cases are usually two-dimensional, but I mean, in reality, a set of coordinates is really a three-dimensional thing. But when you first start studying physics, you typically reserve or start by looking at one-dimensional problems. So we're just going to talk about what happens as Timmy kind of moves back and forth here in a one-dimensional sense. So we would describe where he's at with an x coordinate here, which basically would be this distance here. So we're going to imagine that Timmy starts out here at x equals plus 2 meters, meaning that Timmy is 2 meters to the right of our origin. Now we're going to imagine that Timmy walks over to here and ends up at x equals 5 meters. Now, the 2 meters is Timmy's original starting point. We usually call that something like x initial, or you could call it like x1 maybe. And the 5 meters is where Timmy ended up. So we're going to call this x final. Now, what displacement is, right? It's equal to your change in position. Actually, I'm going to go back and put 3 bars. It's defined as your change in position. And in this example here, what that would be is a delta x, a change in x. And whenever you calculate a change, you always do final minus initial for any quantities. So in this example, that's going to be 5 meters minus 2 meters, which is 3 meters. Now, you'll notice that it's positive 3. You don't necessarily have to write the sign, but that's kind of important because when you calculate a displacement, even in a one-dimensional problem here, you could get a positive or negative number. In this case, a positive number. And what that means is that Timmy moved 3 meters to the right. That's our displacement, our change in position. All right. Now, let's go through a few more examples here of calculating displacement. So I'm going to get rid of this. We're going to imagine that Timmy starts out at 5 meters and then walks over to here, where Timmy's final coordinate maybe is something like 2 meters to the left, or negative 2 meters. Now this is now our final x coordinate. I'm going to go back and change this because in this example, this is now an initial x coordinate. We're going to go ahead and calculate Timmy's displacement. So our delta x is going to be our x final, right? That's what this is, the negative 2 meters, minus our x initial, that's going to be minus 5 meters, and we get negative 7 meters out of that. And let me write that a little better. And again, you'll notice that this came out negative, and what that means is left in my picture. So displacement is an example of what's called a vector quantity. Vectors have magnitudes and directions. The 7 meters is the distance from here to here. And the minus sign is indicating left, so there's a direction. All right, let me get rid of this, and I'm going to go through a third example. All right, now we're going to imagine that Timmy starts out at this negative 2, walks over to plus 5, and then back to here, ends up at 0. So basically the trip we're talking about kind of looks like this, from here to here and back to here. I'm going to put a mark on that plus 5 for a moment. In this example, this is now an x initial, and our x final is 0. Now, when you calculate a displacement, you only look at where did Timmy start and where did Timmy finish. Our delta x is going to be x final, which is now 0, minus x initial, which is negative 2 meters, and we get plus 2 meters out of that. So a couple important things here. One, you notice they came out positive, which means to the right in this example. Timmy moved this way, the overall net effect of Timmy's path. And again, you notice we only worry about the initial and final coordinates. The fact that Timmy ended up over here for part of the time does not matter when we calculate his net displacement. And I'll put a qualifier over the time intervals that we're looking at, calling this the initial spot and this the final spot. Now, if we were to calculate the total distance Timmy traveled, that's different. Because now we would add it all up. Timmy traveled 2 meters to here, and then 5 more, that's 7, and 5 more back. So that'd be, I guess, 12 meters. And again, this partially illustrates the difference between distance, which is just a number, a scalar quantity, and displacement, which is a vector quantity. So again, I want to try to keep this video short. So what is displacement? All right, it's defined as, that's what 3 bars means, the change in position of a system, object, particle, whatever it is you're looking at. And you calculate it by taking your final position minus your initial position. And that's what this would look like in a one-dimensional problem. And I'll make other examples for 2 and 3-dimensional problems. So I'm going to call that good enough. I hope that this video helps answer the question, what is displacement? And hopefully after watching this video, you have an idea of how to calculate a displacement.